All right.
This lesson, it's just a continuation of 10.4. Couple definitions for you. Circles can be tangent as well. Remember, tangent means, like a tangent line is just a line that touches the circle in one spot, right? So if this was a tangent line, it would just touch the circle at one point. So if circles are tangent, that means they just touch each other at one point. And so circles can either be externally tangent, which you need to know because there's problems in the book that'll say, hey, two circles are externally tangent. And that will help you because it gives you information. You could draw a line that passes through the point where they intersect and hits the center of both circles. And whatever this radius is, plus whatever this radius is, well, that's what equals that line. So it gives you more information if they're externally tangent. Circles could also be internally tangent, which means that you've got a smaller circle inside of a bigger circle and they touch at one place. Now, a couple other definitions for you. We've got a line of centers. A line of centers is just a line that connects the two centers of a circle. We've got common internal tangents. A common internal tangent is a tangent line that is tangent to both circles. That's why they call it common. Internally tangent lines go in between the two circles, like so. Common external tangents are tangent to two circles, but they're external, it's on the outside, it doesn't go in between the two circles. And so you need to know these three things. The problems that you'll do today are more challenging than yesterday because you're going to have problems like this. Now, you have to create some sort of relationship between everything that you have here, and for this problem, you have to solve for x. And so, given AB is an external tangent, it's a common external tangent, which means that this line AB is tangent to this circle, which means there's a right angle there. This is also a tangent to this circle, which means there's a right angle here. Remember, that's the definition, or that is a theorem of tangent lines. The radius is perpendicular to the tangent line at the point of tangency. And so here we have two right angles. If we need to find the length of AB, now what will help you is if you draw a line of centers. The reason why that helps is because you know that if this radius is 18, then this little piece will be 18 as well. And if this radius is 8, well, this little piece, it's a radius of the other circle, it'll be 8 as well. And so, let's see. I don't know if it's going to help for me to draw this for you. Maybe we'll flip it. Maybe we'll flip it. There we go. So basically, I'm drawing this shape for you. This is X. The longer side has A, so this would be A, this would be B. This would be the center of that circle. I don't know, let's call it O. This would be the center of that circle, let's call it P. Just flipping it so you can see more clearly what's going on here. Now, let's see. So we have a type of shape here. It's not exactly a rectangle, but let's fill in what else we have. So this radius OA is 18, which means that is 18. And this radius is 8, BP is 8, which means this is 8. Now, can't we draw a line here that would be perpendicular? Yeah, we can draw a line anywhere we want. So, and this is the key to solving these problems. So if I draw this line and this is perpendicular, it means that this side's perpendicular as well. There's a right angle here. And so what I have here is a rectangle. which means properties of rectangles says that if this is x, this is x as well. And so it might help for me to draw another triangle here, just so we can see more clearly what's going on. This is that triangle drawn here. So if that's x, then this will be x, right? And then of course this is still OP. And whatever that point is, let's not name it, it's there, right? Another property of a rectangle, well, the opposite sides are congruent, right? Which means that if this side's 8, this side will be 8. But if the total here, the total's 18, which means that if that's 8, then this little piece is 10. Do you see what I'm saying? Now, it might not be drawn to scale, but that doesn't matter, because I'm creating a system. These things have to be true. I created a rectangle, side opposite of a rectangle, they're congruent, so that's 8. If the total's 18, that has to be 10. And so you could see it here if I drew it on the diagram. Well, I created a rectangle, which means that if this total is 18, if that's 8, that's 8, which means that this little leftover piece here is 10. And so that's what we have going on here. And so I need to solve for x, like that's what I'm trying to do. And basically I created a triangle that I know is a right triangle. And I found other pieces of information with knowing the properties of a rectangle. And so this is 10, right, this little piece? Okay, let's see. Do I know OP? Well, let's take it back to the original. This is OP, isn't it? 18 plus 8, what is that, 26? So OP is 26. And so now I could solve for x. I have a triangle, it's a right triangle, and so I could just use Pythagorean theorem. What's my hypotenuse? 26. So 26 squared equals 10 squared plus x squared. Now I'm solving for x, so I like to put x on this side. X squared is really going to equal, I'm going to subtract 10 squared from this. 26 squared minus 10 squared, okay? That means that x equals the square root of 26 squared minus 10 squared. And I don't have my calculator out here, so let me just look to see what the answer is. Yes. So if you did all that work, you would find that x is 24. This is an example problem that uses a common external tangent. Okay, what about problems that give you, or that have a common internal tangent, like this problem here? Now, pretend that the original problem was in green, and that everything I drew in black here was stuff that you would have to draw to figure out this problem. So it says find the distance between the centers of these circles. Now I haven't drawn that yet, but the distance between the center of the circles is this line here. Given that the common internal tangent is 15. Here's the common internal tangent, it's 15. Again, the key is to create a bunch of rectangles, because tangent lines make right angles with the radius. And so if you extend this radius, it was given that it was 8. If you extend this radius, you just draw a line, just extend that line, and you draw a line here such that this is a right angle. What you've created here is a rectangle, because that is definitely a right angle, that was given. This was a right angle, that was given because it's a tangent line. And I just drew these lines such that they are right angles. So I've created this rectangle here, which means that if that radius is 5, then it's a rectangle, so across from that is 5 as well. Now whatever this is, whatever 15 is, whatever this is, this will be the same, right? So this is 15 also. And I've created a rectangle up here using the same process. If that's 8, then that'll be 8. If if that's 15, then this will be 15, right? And if I need to solve for the distance in between the circles, okay, well, let me just draw that line here. I need to solve this distance, right? And so you could see I've created a rectangle here, or a triangle, I'm sorry. And I'm gonna draw it here for you. Let's just call this D, because that's the distance we're looking for, right? The distance between the centers. I've created a triangle. I figured out that this was 15 because I drew extra lines. I drew auxiliary lines. And they gave me that this was 15, right? So now I know that that's 15. And I know that, well, this side here of the triangle is 8 plus 5. So what is that, 13? Okay, okay. Well, let's see. Is that a, well, it's a right triangle, so I could use Pythagorean theorem. Is that a special? No, that's not a special one. Okay, so I can still find the distance D. D squared equals, using Pythagorean theorem, 15 squared plus 13 squared. So D is just the square root of whatever 15 squared is plus 13 squared. I'm sure you can find that using your calculator. I won't show you the answer here. It's just an example. If you have an internal tangent, you just have to create rectangles. If you have an external tangent, you have to create rectangles. And then you need to find some triangle and use the Pythagorean theorem.